Good morning students and welcome to our YouTube channel Non-Linear Models. So in the previous videos we have just completed the theorems which were given from theorem 8.2 to 8.7 theorems we have just completed. So first of all let us revise all the theorems. Okay, so from 8.1, that was a diagonal of a parallelogram divides it into two congruent triangles. We have seen that if we just made a parallelogram, see, I just made a parallelogram over here, then what happens? Parallelogram A, B, C, D. When in the parallelogram a diagonal divides the parallelogram into two parts, then they form the two congruent triangles. So ADC is congruent to AB and C. Okay students, this was the first theorem. Second theorem, that is in a parallelogram opposite sides are equal. In a parallelogram opposite sides means this and this are equal. And in the next theorem, that was theorem number 8.3, we have seen if each pair of opposite side of a quadrilateral is same, then it is a parallelogram. Means if in a quadrilateral the opposite sides are same, then it is a parallelogram. In theorem 8.2, what we have seen? In parallelogram the opposite sides are equal. In theorem 8.3 we have seen that if in a quadrilateral the opposite sides are equal, then it is a parallelogram. Next theorem, that was theorem number 8.4. In a parallelogram opposite angles are equal. In parallelogram opposite angle means this angle and this angle is same, this angle and this angle is same, opposite angles are same. And in next theorem we will prove its converse. That is, if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. If in a quadrilateral each pair of the opposite angle is same, then it is a parallelogram, that we have seen. Then after the another one, that is 8.6, theorem number 8.6, that is the diagonals of a parallelogram bisect each other. Means here the diagonals which are drawn from the parallelogram, they bisect each other. Let us give a name O. Okay, they bisect each other. Then after here, next theorem, that is if in a quadrilateral the diagonal bisect each other, then it is a parallelogram. Okay, that is theorem number. If the diagonal of the quadrilateral bisect each other, then it is a parallelogram. So up to this, that is theorem number 2, 3, 4, 5, 6 and 7. That this all the theorems that we have seen in the previous video. Now here comes the example, but from this chapter also there is no example, only there is a sum, one sum of exercise 8.1. But before that we come to the another conditions for a quadrilateral to be a parallelogram. Another condition for the quadrilateral to be a parallelogram. Let us see that first of all. That is, you have studied many properties of a parallelogram in this chapter, and you have also verified that if in a quadrilateral any one of those properties is satisfied, then it becomes a parallelogram. We now study yet another condition, which is the least required condition for the quadrilateral to be a parallelogram. It is stated in the form of a theorem as given below. So here comes the theorem number 8.8. Let us write that first and then we will understand this. So theorem number 8.8, that is A quadrilateral, a quadrilateral is a parallelogram, is a parallelogram if a pair of opposite side opposite sides is equal and parallel. Okay, here we come to the theorem 8.8, that is a quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Sorry, we have to write here parallel, not parallelogram. I'll just write with the flow. Okay, it is parallel. Again reading, a quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. Means they are telling that if we just drew a quadrilateral, if there is a quadrilateral, then after, okay, this is a quadrilateral, that is, if I give name A, B, C and D, then they are saying that in a quadrilateral is a parallelogram if a pair of opposite sides, opposite sides means this and this is equal, means the length of this and this is equal and the length of this and this is equal and they are parallel to each other. If they are parallel to each other, means if I give that this is 5 centimeter, then this must be 5 centimeter, and if I give this is 6 centimeter, then this must be 6 centimeter. Okay, then only, and I just forgot about the parallel. If this is 5 centimeter, this is also 5 centimeter, then if this both lines are parallel to each other, this both lines are parallel to each other, then it is a parallelogram, and also these two lines are equal, means if this is 6 centimeter, then this will also be 6 centimeter, and this is parallel to this, they both are parallel to each other, then only it is a parallelogram. See here the theory which is given over here, that is, reading it again, a quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. Then here it is proven by the SAS, means side angle side theorem, that is, look at the figure 8.17 in which AB is equal to CD and AB is parallel to CD. Let us draw a diagonal AC. You can show that triangle ABC is congruent to triangle CDA by SAS congruence rule. So BC is parallel to AD. Okay, so that is parallel to AD. And here comes an example number 6 that we don't have to do. Then after comes here exercise 8.1. From that only question number 1 is to be done, else all the questions are cutted by the government guideline. Here you doing the question exercise 8.1 question number 1, that is, question is exercise 8.1, that is the angles of quadrilaterals are in the ratio that is 3:5:9:13. Find all the angles of quadrilateral. Here the angles of quadrilaterals. Angles of quadrilateral is in ratio that is 3:5:9:13, and we have to find each angle of the quadrilateral. So we know that the sum of the quadrilateral, the sum of all the sides of the quadrilateral, that is 360. So if I take 3x, 5x, 9x and 13x, and the sum of these four angles, that is 360 degree. So if I just do the sum, that is 3x plus 5x plus 9x plus 13x, then it will be 360 degree. It will be 360 degree. Okay students, here 5 plus 3, that is 8. 8 plus 9, that is 17. 17 plus 3, that is 20. 20 plus 10, that is 30, is equal to 360. So here I can write 30x is equal to 360 degree. And here we know that we have to solve this equation. If this 30 will move towards this side, it is here in the multiplication. When it just move towards that side, it will be in the division. So here x is equal to 360 upon 30. 0, 0, cut. Then after 3 1s are 3, 3 2s are 6. Here we get x value is equal to 12 degree. X value is equal to 12 degree. And here we have to find out all the angles of quadrilateral. So here, if I say 3x, we have given here 3x, then it will be 3x is equal to 3 into 12 is equal to 12 3 is 36 degree. This angle is 36 degree. Another angle, that is 5x, is equal to 5 into 12. 5 into 12, that is 12 5s are 60 degree. Then after comes 9x, that is, you can do this 9 into 12. So what will be it? And then after 13x, that is 13 into 12. Okay students, this you have to write by your own. Okay, please write down this sum, and then after we will move further. So here it will be 108, and here it will be what? 13 into 12, that is 0. 3 1s are 3, 1 1s are 1 plus 6, 2. So 156. Okay, 156 degree. Okay, so this is our answer. Please note down this. And then after, here we will move towards new topic, that is here 8.6, the midpoint theorem. 8.6, that is the midpoint theorem. Let us see that. So here the topic number 8.6, that is the midpoint theorem. The midpoint theorem. Here, see here, it is written, you have studied many properties of a triangle as well as quadrilaterals. Now let us study yet another result which is related to the midpoints of the sides of the triangle. Perform the following activity. Draw a triangle and mark the midpoint E and F of the two sides of the triangle. Join the point E and F. Measure EF and BC. Measure angle AEF and angle ABC. What do you observe? You will find that EF is equal to half of BC and angle AEF is equal to ABC. So EF is parallel to BC. Repeat this activity with some more triangles so you can arrive the following theorem. Here they are just telling us, first of all you have to draw a triangle. If I see here, I haven't drawn the perfect triangle because I don't have scale. Okay, here I give A, B and C, the triangle ABC, and here we have to draw E, and here we have to draw F. So they are telling us, when you just measure EF by just joining, when you just take the midpoint of AB and AC and you get the 2 points, that is E and F. Okay, then after what you just do, you just measure EF by joining and measure BC by that we have, then you will get EF is equal to half of BC. Okay, means if you have got here BC is equal to 10 centimeter, I am just giving the example. So here it will be 5 centimeter, and also the angle AEF is equal to angle ABC. Angle ABC. Okay students, angle A, B and C. So now they are telling, and according to the midpoint theorem, the midpoint where in the triangle there is a midpoint, the length will be half of the base. Okay, length will be half of its base, and the angle ABC and angle AEF will be same and they will be parallel to each other. Okay students, so this is about the midpoint theorem. Then after, there is another theorem, that is theorem number 8.9, that is the line segment joining the midpoints of the two sides of a triangle is parallel to the third side. Okay, here they are telling the line segment joining the midpoint of two sides of a triangle is parallel to the third side. Here theorem number 8.9, that is line segment joining the line segment joining the midpoint of two sides of a triangle is parallel to the third side is parallel to the third side. And the another theorem, it is its converse theorem that I am just writing with it only. So theorem number 8.10, that theorem, these both are converse of each other. So that is 8.10. The line drawn by, the line draw through the midpoint of two sides, one side of a triangle parallel to another side bisect the third side. First of all, let us understand this theorem. Okay, students. Here, the line segment joining the midpoint of two sides of a triangle is parallel to the third side. Here, if I just draw a triangle, suppose this is a triangle, okay, and you can see with the picture which is given, I am just giving the name according to that only, that is A, B, C, and the third line, that is from here, that is ABC is given, then a midpoint which is passing, that is EF. Here it is E, F and D. So from here we have to prove that, what we have to prove, the line segment joining the two midpoints of two sides of a triangle is parallel to the third side. The line segment joining the two sides of the triangle is parallel to the other side also. That is, we have to prove that according to, you have to prove this theorem using the following clue, that is observe figure 8.25, in which EF and E and F are the midpoints and O of AB and AC respectively, and CD parallel to BA, CD parallel to BA, this is parallel to it. So for that we have to just find that CD is parallel to AB. So for that, triangle AEF is congruent to triangle CDF. AEF is congruent to CDF. These both triangles are congruent to each other. Then after, so EF is equal to FD and DC is equal to AE. All these sides will be equal. Then after, therefore, BCDE is a parallelogram. This gives EF is parallel to BC. This gives EF is parallel to BC. And in this case also note that EF is also half of ED and half of BC. Okay students, then after we have to prove its converse theorem. Okay, here again reading the line segment joining the midpoint of two sides. Line segment joining the midpoints of the two sides is of a triangle is parallel to the third side, is also parallel to its third side. Then after, here it's the converse, the line drawn through the midpoint of one side of a triangle parallel to the other side bisect the third side. Okay, here it is its converse. How? See, the line drawn through the midpoint of one side being from here, we have drawn a midpoint. Then after, of a triangle parallel to the other side, it will be parallel to its other side, bisect the third side. Okay students, here also its proof is given, its converse, that is in figure 8.26. So observe that E is the midpoint of the AB line passing through E is parallel to BC and CM is parallel to BA. That is, prove that AF is equal to CF by using the congruence of triangle AEF and triangle CDF. Here we have to prove AF is parallel to CF. Okay, sorry, is equal to CF. That we have to prove. That we can prove. Why? Because this AEF is congruent to AEF is congruent to CDF. Okay students, so according to the congruence theorem, this congruent rule, we can just prove that AF is equal to CDF. Okay students, here we just complete our chapter. I think, yes, we have completed our chapter. So in the homework, what you just do is, so in your homework, you have to do the theorem, that is 8.8, 8.9 and 8.10, and the midpoint theorem. The midpoint theorem. Okay, the midpoint theorem, and then we will meet in the next video. Okay, bye students, with our new chapter.